Okay, so in this video, we're going to talk about an application of a system of inequalities, and in particular, how a graph of a system of inequalities can help us determine a solution given a particular situation. So we're going to talk about this little word problem here, and this may be a two-part video just to make sure that I explain everything as in-depth as I possibly can, so we know exactly where everything is coming from, okay? So I'm going to go ahead and start reading this problem, and I'm going to kind of make a list of important pieces off to the side. So we have Emma, and she works 2 jobs during her summer vacation. She works at least 8 hours as a nanny a week, okay, and at least 12 hours at a pet store. Okay, so we know that she is working at least 8 hours as a nanny a week and at least 12 hours at a pet store per week. Okay, now she makes, man, 15 bucks. She makes 15 bucks per hour. She makes 15 bucks per hour as a nanny. Okay, and she makes $10 per hour at the pet store. Okay. Write and graph a system of inequalities that could be used to find combinations of hours worked at each job where she makes at least, we want at least 300 per week, but works no more than 30 hours in a week. Okay, now I like kind of writing some things off to the side. I like writing that important information off to the side so I know exactly what I'm going to be using. I mean, highlighting works as well, but I just find that kind of making a list and going through that list and making sure I hit every single piece of it just kind of helps me set up the problem a little bit better. Okay, now, we got to figure out what our variables are going to be. We got to figure out what our variables are going to be. And a lot of the times, the question or kind of what we want out of the situation tells us exactly what the variable should be. It says, write and graph a system of inequalities that can be used to find combinations of hours worked at each job. We want to find combinations of hours worked at each job. So we have 2 jobs. The amount of hours we can work at each of those jobs can change. There's our variables. Okay, so I'm going to say X is the number of hours as a nanny. Okay, I'm going to say Y is the number of hours at the pet store. Okay, because everything kind of depends everything else kind of stems from how many hours Emma works at each particular job. Okay, she can work at least 8 hours as a nanny, 12 hours at the pet store. She makes different amounts at each, and the constraints are really dependent upon how many hours she works at each job. Okay, so these are our variables. Okay, and now that we got our variables, I'm actually going to go ahead and label each axis. Okay, that's very important to do. So we got we have our x-axis, and that's how many hours she works as a nanny, and we have our y-axis, pet store, and it's how many hours she worked at the pet store. Okay, so we have our x and our y-axis labeled. Now we gotta make sure we write a system of inequalities. Okay, so let me go ahead and do this in a bit of a darker color so you can see it on the graph. Yeah, I'll go ahead and use this. All right. Now, she has to work at least 8 hours as a nanny. Well, X is the number of hours she works as a nanny. So the amount of hours she works as a nanny each week is at least 8 hours. So X is greater than or equal to 8. And she also works at least 12 hours at a pet store. So that's going to be Y greater than or equal to 12. Okay, X is how many hours she works as a nanny. That's at least 8. Y is how many hours she works at the pet store. That's at least 12. So these are 2 of our inequalities for this system. Okay, now she has to make at least 300 per week. We know she has to make at least 300 per week. Well, how do we get there? How does she get there? Well, she makes 15 as a nanny per hour. So if we do 15x, this is going to tell us exactly how much money she makes every single week as a nanny. If she works 2 hours as a nanny, that's going to be 30 bucks cash. Okay. If she works 10 hours as a nanny, it's going to be 150 bucks cash. So 15x tells us how much money she makes working as a nanny. Okay. and she makes $10 per hour at the pet store. So 10y is going to tell us how much money she makes at the pet store, okay? So 15x, how much money she makes as a nanny. 10y, how much money she's making at the pet store. If we add these two together, that's her total take-home pay for the week, and she wants to earn at least $300, okay? So we want her take home to pay to be at least $300. So we have our third inequality. So we already talked about all of this. Now we just want to make sure that she doesn't work more than 30 hours a week, okay? Well, if we take how many hours she works as a nanny, which is X, and how many hours she works at the pet store, which is Y, and add these two together, that's how many total hours she's working in a week. We don't want it to be more than 30 hours, so we say less than or equal to 30, okay? So this here is our system of inequalities, okay? This here is our system of inequalities, all right? So now that we have our system of inequalities, we need to go ahead and graph it, okay? But in order to make sure that this video doesn't run too long, I'm actually going to stop right here. Feel free to go ahead and try graphing this on your own, and in the next video, we will go ahead and actually take a look at the graph and some possible solutions for this particular situation, okay? So go ahead and feel free to graph, but in the next video, we're going to go ahead and take a look at that graph in particular, all right?